I'm going to introduce our first speaker of today. That is Professor Alappat, of Civil Engineering at IIT Delhi. And he's going to talk about understanding environmental problems and their solutions. I think Professor Alappat, I think, holds a PhD in environmental engineering from IIT Delhi. My alma mater, and he also holds a postdoc from Science and Base France. He has more than 28 years of teaching research experience. So currently he is a professor at environmental engineering in the Department of Civil Engineering at IIT. He is also a visiting professor in the Department of System Energetics and Environment, IMT Atlantic, Nantes, France since 2004. He specializes in environmental engineering, especially on the incineration techniques, fluidized bed reactors, and solid waste management. He's published more than 200 research papers in international and national journals and conferences. He's also a reviewer of many international journals. He's also guided several PhD and MTech projects, and you might want to be one of those someday. His contributions in the area of waste management includes both incineration techniques and landfilling. The Landfill Pollution Potential Index and Leachate Pollution Index, developed by Professor Alappat and his team, has been in extensive use for quantifying the pollution potential of uncontrolled landfills. So it's very interesting topics that he's going to be talking about, which is very relevant for us. Also, he has worked extensively on fluidized bed incineration of liquid and solid waste, especially in recirculating fluidized bed reactors. Presently, he is active in the research on the incineration of municipal solid waste for energy recovery. His research team recently formulated a technique to assess the incinerability of municipal solid waste, named I-Index, and prepared an incinerability map of India. And he's also a consultant to many governmental and non-governmental organizations and technical experts in many committees. So let's give him a big round of applause, and I welcome Professor Alappat to take the stage. Thank you.
So good afternoon. Oh, thank you. Normally we teach here in this room, so when I say good morning or good afternoon, normally I don't get anything back. So I'm so glad that you people responded very well. Thank you very much. Okay, I am Babu Alappat, and before I start my presentation, I wish to thank Madam Professor Shilpi Sharma, who is sitting there, who is our Dean Outreach, and Professor Dariwal is also here, the one who introduced me. There was actually no need to introduce me in such a length anyway. Okay, thank you very much for coming here. I understand that you are students from different schools. So thanks a lot for coming here. And do you know, I have a daughter of more or less of your age. She told me, Papa, Ajkal you have become a kind of person who gives a lot of advice, many pieces of advice. So she told me clearly, if you are going to speak to the students, don't give any advice. So here I am, not to give you any advice. Okay, I will not tell you what to do, what not to do. I think it's not correct. I will share some of the experiences of myself, my team, or people in Delhi. Okay, maybe you people yourselves. I prefer to switch it off. Yeah, keep it off, please. That's enough. Keep it off. Yeah. So I will not give you any advice. Okay. Second thing, I should admit that I am envy of you people. You know why? The reason is you people are so young and so youthful that you get so many ideas. Maybe some ideas are stupid, some ideas are not really good, some ideas are illogical. But please understand that over age, when you become grey like this, you will not get very innovative ideas. So this is the age, I'm sure, you get a lot of good ideas, inspirations, new themes and imagination. Yeah, okay. But keep it minimum requirement. Okay, so sorry, I think something is going wrong. So that is why I am envy of you guys and girls. Okay. So at the end of the presentation, in case you have some ideas to share, some questions to ask, please don't shy away. Just ask. Some of the questions may not be very good, but I am very sure you will get a lot of ideas. Please discuss these ideas with your teachers and your mentors in the school, and some ideas can actually click, really click. Okay. So let us move on to the topic. There are many environmental issues. There are many environmental issues. Some are at global level. We call it macro issues. Some are at local level, very small, micro level. So the issues that are at a global level, I think I am not planning to touch upon today, although they are very, very interesting. Okay. Today, I have chosen some of the micro issues so that you can understand it better. I am sure some of these macro issues, the global issues, I am sure some of you must be knowing quite a bit about it. But the list is very interesting, global warming. Everyone knows that the effect of global warming is actually manifested these days in a big way. What kind of rains we are having? Okay. When we were all young, okay, I'm 60 now. When we were young, the rainfall pattern was entirely different. Now you can see rain comes like a hurricane, and in 1 hour you have a rain that was actually meant for 2-3 weeks or a month. So that kind of rain ensued, followed by flood and other kind of things. So the global warming is actually showing up these days, and there are many issues. Pollution of the oceans. Do you know? Just 2 weeks back, there was a ship that actually sank in the Kerala coast, very near to Kerala coast. They were carrying about 640 big containers containing carbide and a lot of other things, which actually can cause a lot of issues, a lot of damage to the ocean, Arabian Sea. Similarly, you can see pollution of the space. There are so many space programs, rockets, and satellites being sent, and so much of remnants near the outer space of the Earth, not far away space, very close to the Earth. There are so many remnants of rockets and satellites roaming around. There is another issue. Pollution can come from the space, like an asteroid hitting the Earth, which can cause huge damage to the lives on the Earth and also huge pollution. Then, weapon testing and war. I don't have to tell you what happens in a war. Other than the loss of lives, plenty of lives, there is a huge damage to the environment. Acid rain, ozone layer depletion, depletion of fossil fuels, emerging contaminants, and you can add on to the list. There are actually n number of global issues. Some of the issues are really interesting. Have you heard about feminization of the Earth? Feminization of the Earth. There are more estrogen mimicking compounds that are actually getting accumulated in the environment. Can you imagine these kind of things? Anyway, these are all happenings. I don't want to get into the detail. I just want to tell you something about that. That's all. Going to the macro level, we will take up micro level, we will take up some local issues. As Professor was telling that today is the World Environment Day, and there is a theme for this Environment Day of 2025, that is actually ending plastic pollution globally. So this is the theme chosen by the government, by the Ministry of Environment and Forest and Climate Change. So I will spend some time to highlight these issues. Then we move on to the micro issues that I had actually planned for you. Act locally to reduce the plastic waste, reduce the usage of plastic materials. Do you know, when plastic was actually made or invented, that was one of the best material. Why it was the best material? You know the reason. It can be made transparent, translucent, opaque. It is lightweight, still having good amount of strength, tensile strength as well as compressive strength. It can be colorful. It can be, without any color. It is resistant to the thermal, heat, resistant to the electricity. What not? Resistant to the acid, alkali. You can have alkali acid storage in that. So many wonderful properties of plastic made it, people started using left and right. Now what is the problem? The problem is there are plastic everywhere, and some of the plastics actually stay back. and they will see you people, your children, and your grandchildren, and their grandchildren as well. Plastic takes a long time to degrade. Okay, but there are a lot of attempts to make biodegradable plastics and the plastic that will degrade very fast. So, for you to feel, I have brought here a biodegradable plastic bag, and inside, if you see, don't try to put your hand inside because it could be slightly dusty. Okay, so don't try to put your hand in. You can just see, you can see the biodegradation happening in this in plastic bag. Okay, so I had a white colored biodegradable plastic carry bag which I got from Big Bazaar or I don't know. So I have been keeping it for the last couple of years to degrade. So in a couple of years, how it has degraded, you can have a look at it. Okay, so I will just give to professor, and it will go like this, like this, like this, like this, like this, like this. We will go to the end. I will collect it at the end of the lecture. I want to start it now because it may take some time. Okay, and also I will circulate one box. Okay, there will be one box following this bag. Wait a minute. And this bag has different kind of plastics. You know, the bag has different kind of plastics, and you can see this emblem. This is the plastic resin code. If you see inside, you can see 4. There is a small triangle like this, and 1 or 2 or 3 or 4 like that. Okay. So this resembles which plastic is this? One is actually phthalate. Second, number 2 is high density polyethylene. Number 3 is polyvinyl chloride. 4 is low density polyethylene. 5 is polypropylene, polystyrene, like that. Okay. So you can feel, you can see, you can look for that triangle and the number. You can see there is a triangle here and the number. So this is actually 4. 4 is actually low density polyethylene. So this is a good opportunity for you to see. If you are having a normal plastic water bottle, normally it is 1. If you see below the plastic bottle, you can see there is a triangle like that and 1. It is phthalate actually. Okay. And there is one more interesting thing. You can see a transparent sheet. This is 51 micrometer thick. Something very interesting. You know why I brought it? Up to recently, 50 was there is a ban on plastic up to 50 micrometer. This is 51, just above the size. So do you know how thick is 50 micrometer? You can do like this and see how thick it is. Okay, so this is 51 micrometer. But actually, they extended the ban recently to 120 microns. So now the ban in Delhi is below 120 micrometer thick plastics are banned actually. Don't ask me whether you get plastics from outside, you get different kind of plastics. Officially, plastic below 120 microns or micrometer is banned. And this is 51, just above the plastic that was allowed to use until I think 2021 or 22 perhaps. So have a feel of the thickness of the plastic as well. Okay. So you can pass it on like this, have a look. Take your own time because we will go for almost an hour and I will take it back at the end. Okay. So this is just something for you to, because I cannot circulate something to eat. So, you can feel it actually. Okay. So this is the resin code. And as per the government directive given, there are some suggestions to reduce plastic. I am just displaying it. This came from the Ministry of Environment and Forest and Climate Change. So I have to read it for you people. Use cloth bag for shopping instead of plastic bags. Carry your own water bottle wherever it is possible. Reuse glass containers or plastic items as storage boxes. Participate in cleanup drives of cities and water bodies. Prefer using non-plastic eco-friendly cutlery using gatherings and events. Use menstrual cups instead of sanitary napkins if possible. Use recycled plastic over virgin plastic. Use steel or recyclable plastic lunch boxes and water bottle. Cut packaging bags for milk or buttermilk only partially to avoid that small rectangular piece that will come out after cutting. So that gets normally mixed with the biodegradable waste, and use non-plastic items like bamboo items and these kind of things. Why I read it for you? These are all common knowledge. I know you people know it. But why I displayed it today? Because today is the World Environment Day focusing on plastics. Okay. So that's the reason why I showed you these things. I am sure, now I go back to the normal lecture of mine. You can see our earth is 4.6 billion years old. Okay, 4.6 billion years old. And you can see if I represent this 4.6 billion years of age of the earth in one day, you can see it starts from here, 1 hour, 2 hour, 3 hour, like that it goes. And finally, it reaches back to 24 hours one day. So this 4.6 billion years of the earth life is actually represented in a diagram like this, in a clockwise manner like this, 24 hours, that is one day. Okay, now you can see when the human beings are appearing in this clock. You know, if you go like this, there was nothing. Earth was so hot and earth was formed and so many asteroids hitting the earth, and after 1.5 billion years only, you know, something is happening. Then 2 billion years, the oxygen is started accumulating in the ocean. It goes on like that. Then after 21.2 billion years, first life is coming here in the 18th hour, then 19th hour, then dinosaurs on the 22nd hour. That means 4.4 billion years. And human beings are appearing in the last 4 seconds. Can you imagine? I hope you understood what I was trying to communicate to you. Earth is 4.6 billion years old. If you put it as one day, 24 hours, human beings are appearing on the earth in the last 4 seconds. Unbelievable. Do you know Mother Earth has been pooling all the resources like coal and petroleum and all those things for the last how many million years? And we are actually squandering it in just 1 or 2 hundreds of years. This is the message I want to tell you, and this is the problem behind almost every issue. Okay, because human beings appear only recently, but Mother Earth has been pulling it for the last how many millions of years. So our greed, our overconsumption of resources are actually causing the issues. Anyway, going ahead, what are the environmental issues? If I ask you this question, what are the some of the major environmental issues of Delhi? I am sure you will be adding on to this list many more. But if I ask you suddenly, what are the environmental issues you face in Delhi? One environmental issue is the ambient air quality. I am sure all of you will agree with me what is happening, especially in the month of October, November, December. It's severe bad air. Okay. So I will spend few minutes on that. Then pollution of the river, the mighty river Yamuna. That is another environmental issue that everyone will speak about in Delhi. Then our waste management system and the mountains of waste we are having in New Delhi. Solid waste management, another issue. And loss of biodiversity, unwanted invader species of plants and trees. There are many more actually. I just picked up a few for you to discuss today. So that's all. And I have put some pictures as well for you. So looking at the ambient air quality of Delhi, we use a index called Ambient National Air Quality Index, AQI. So that's an index normally used to quantify or to communicate what is the pollution level of the ambient air in Delhi. Okay. So you can see this is nationally used, not only in Delhi. It is AQI on a scale of 0 to 500. 500 is the worst scenario and 0, normally it cannot be 0, it is the best scenario. So this AQI, the index vary from 0 to 500. So 500 is the worst you can imagine. And how they made it? These calculations are actually based on different pollutants of the ambient air, that is particulate matter. We call it PM10, PM2.5. PM2.5 means 2.5 micrometer and below, very small size. Okay. And PM10 means 10 micrometer and below. So these are the particulate matter normally we consider. Then carbon monoxide, ground level ozone, SO2, nitrogen dioxide. So all these pollutants are actually measured, and I don't want to show you the calculation, and they will calculate AQI. Okay. And AQI is a number from 0 to 500. Lower the number, better for us. And see the scenario. And the color yellow is given to the range green is given to the range 0 to 50. What is written? Air quality is satisfactory, no problems at all. Yellow, the number is 51 to 100. Air quality is acceptable, but there can be some problem to some people. Orange, 101 to 150. Red, 151 to 200. Purple, 201 to 300. And maroon, 301 and above. And the last one is health warning of emergency condition. Everyone is likely to be affected by this severe air pollution. Now I ask you, what is the air pollution AQI of Delhi now? I am sure you will be able to check the Google. It is about 120 to 130. It varies. So where we are, you can see we are in the orange range. Even today. And if I please hold your desk tightly so that you won't run away from here. You know, in October, November, do you know what was this value? It was more than 500. Can you imagine this AQI value? The upper number is 500, and some of the calculation shows that value even offshooted more than above 500. And the values very close to 300, 400 are not at all abnormal in Delhi. This is not to scare you, but to tell you the reality. Okay, so this tool AQI, Air Quality Index, is a very interesting tool, and you can see even when you drive or when you travel in the bus, you can see Air Quality Index of today. You know, if you go to Andaman and Nicobar Islands, do you know the air quality AQI number? It will be 20, 30. If you go to Lakshadweep, badhiya, you will have it at 30, 40 in that range. Unfortunately, our capital is at a very high level. Okay, today it is 120, 125, something like that. What is the reason? The main reasons are emissions from the automobiles, from the industries, from the thermal power plants, from the construction and demolition sites, street sweeping, open burning of biomass and waste, resuspension of dust, and there are many more reasons. So what are the solution? Stop automobiles, industries shut down, thermal power plants shut down, no construction, and street sweeping, let us don't sweep the street. Is that the solution? See, this is where environmental engineering comes into action. Environmental engineers. Okay, I am not telling you about environmentalists, I am telling you about environmental engineers and environmental scientists. If there is a problem, we have to understand the root cause of the problem. What are the issues causing these kind of emissions? Okay, and then we have to work, there are engineering and scientific solutions to bring down the pollution. That is what we have to learn. For example, I told you these are the sources of emission, automobiles. I am sure you must be knowing about petrol engine, diesel engine, and diesel engines are slightly more polluting than petrol engines. And there are different standards, BS 3, 4, different levels of air quality, emission standards. So what I want to tell you is, different industries have different emission standards. And we have to ensure that, the industries have to ensure that they are within actually that emission levels. This is the first step that we have to see. So, CPCB, what is CPCB? Central Pollution Control Board. Central Pollution Control Board, State Pollution Control Board, these are the organization, India government organization, they put the standards, the emission standards, etc. Okay, so if you take any industry, cement industry, thermal power plant, steel industry, there are emission standards. I will give you an example. Okay, I will give you an example after this. So, if the industries can comply with the emission standards, half of the job is done. You know how many industries are there in New Delhi? Do you know how many brick kilns are all over there around Delhi? We have a lot of construction happening. Have you seen people making bricks in Delhi? Bricks come from the neighboring states, Haryana, UP, all those neighboring states. There are more than 1,500 brick kilns all around the Delhi. They are all generating all kind of emissions that can end up in Delhi, depending upon the wind direction and all those things. How many industries are there in Delhi? We have huge thermal power plants. We have how many lakhs of vehicles flying. So there are standards, emission standards for all these things. For example, I will give you one standard for thermal power plants. All thermal power plants that are installed after 2017 1st January, you can see the standards. Particulate matter, it should be less than 30 milligram per normal meter cube. Sulfur dioxide, less than 100 milligram per normal meter cube. Oxides of nitrogen, mercury, these are called the emission standards. So I just showing you one example, and maybe there are more recent standards for thermal power plants. And there are many moves to shift to electric vehicle. What is the beauty of electric vehicle? Electric vehicle will not emit when you use them. But you have to charge them with the electricity. Electricity is generated in thermal power plants, coal burning thermal power plants. So your pollution shift from all over the roads to a source where we can have a better control. That is the beauty. Okay. Otherwise, I don't know, we have to do a life cycle analysis to see whether electric vehicles are actually, shifting pollution, changing pollution. But what I want to tell you is, on the roads, they don't emit anything. But they have to be charged. Power plants are making power by burning coal, mostly coal and other fossil fuels. So the pollution happens there, not on the roads. Okay. But we have better control to control emissions and all those things in a power plant. On the roads, everybody emits, so it's very difficult to control. Anyway, so using public transport systems like metro, rather than everybody driving his car or scooter, alternate management of strategies for biomass and agro waste, no open burning, no dumping of waste. I am sure you must be remembering, Delhi people, we complained that in Punjab and Haryana, all those farmers burn their stubble, their agro waste in the month of October and November. Sometime I feel that Delhiites have no right to blame them. Do you know why? In last Diwali, there was a ban on the fireworks. And we people, Delhi people, enjoyed the fireworks, doing all kind of burning of crackers and everything in last Diwali, knowing that there will be an air pollution coming very soon. Severe air pollution from October, November. So can't we at least sacrifice those fireworks of a day or two? We did not do. Then why should farmers of Haryana and Punjab sacrifice? We cannot blame them actually. I hope you understood my argument. If we cannot sacrifice 1 or 2 days of Diwali or Christmas or New Year fireworks, how can we blame them? But it was not there in the past. Why it was not there in the past? Stubble burning all around Delhi, it was not there in the past. In the past, they were not only harvesting the grains, but they were actually using the stubble, that thatch, that hay, what is that, biomass as well, for the cattle feed, and there were a lot of application for the thatch. Now, the machine cutting is happening in a big way, and they are worried about only the grains. So, a lot of the plant actually remains, nobody wants to collect it. The easy way is to fire it. That is what is happening. Okay, it's not the right thing. If you can compost it, there are many ways. There are a lot of research happening in that direction. The people collect that, shred it into pieces, and gasify. They can make fuel gas and run electricity and engines to generate electricity. It's possible. And they can actually shred it into pieces and add some inoculum and compost it. These are all lignocellulosic material, very difficult to degrade. Your kitchen waste is actually very easily biodegradable, but not the biomass and the lignocellulosic waste like rice plant or gehum plant and wheat plant, all those things. A lot of research is happening in that direction, and I am sure we will be having a better scenario very soon, and the Haryana, Punjab and the UP farmers will stop burning their stubble, so that Delhi will be saved at least from the wind, the polluted winds coming from these open burning sites. But we should do our job. What is our job? At least we should sacrifice our firecrackers and all those things, whatever be the celebration it is. Okay. Anyway, going ahead. Now, pollution of river Yamuna. Something very interesting. If I ask you, there is some very interesting parameter called dissolved oxygen. How much oxygen can be dissolved in a river water? Okay. And the maximum at 0 degrees centigrade, 1 atmospheric pressure, it's about 14 milligram per liter. That's all. Okay. In the normal scenario, there is Henry's law. I am sure some of you must have heard about Henry's law. Depending upon the pressure, how much is the solubility. Okay. Some of you might not have heard about it. Don't worry. According to Henry's law, maximum 14.2 or something like that, 14 point something can be dissolved in water. Actually, that is very little. If you dump organic matter into any river, any stream or river or pond, the oxygen level will go down because the bacteria present there can utilize this dissolved oxygen to stabilize, to digest the waste, organic matter. And DO level, dissolved oxygen level can go down. In river Yamuna, the saturation value, kitna tha? 14 point, the saturation value. Normal value can be 8 to 9 milligram per liter. In the normal scenario, 8 to 9 milligram per liter. Because atmospheric temperature is not 0 degrees centigrade. By the way, am I speaking very fast? Oh, this speed is okay? Can you follow my English? Because I am from Kerala. My mother tongue is not English. My mother tongue is Malayalam. So I speak Manglish. You know what is Manglish? Malayalam plus English. And you know what is Tanglish? Tamil plus English. So don't worry, my pronunciation may not be very good because it's a mixture of Malayalam and English. So I hope you can understand this Manglish. Very good. Should I slow down? Not required. Okay, very good. So the question is, the normal value of DO is 8 to 9 milligram per liter. If it goes below 4 milligram per liter, all fish population will vanish. If it goes below 2 milligram per liter, most of the aquatic life will perish. Do you know the normal DO level of river Yamuna? We do it actually. My team, our team in the department goes and we frequently monitor all these things. It can go even very close to zero, even zero. Zero means there is no dissolved oxygen at all in Yamuna. That means it is septic. The condition is anaerobic. There is no dissolved level at all, dissolved oxygen at all. And you can see a lot of aquatic life will perish. I will show you one picture. See, when dissolved level goes down, you can see all these fishes were very happy. You can see there are all kind of aquatic animals. And when dissolved oxygen goes down, you can see finally below 2 ppm, 2 ppm means 2 milligram per liter. Very dangerous. You can see only some crazy creatures are existing. Then, if the river can come back to normalcy, normal scenario, then all these people will come back. They will come back, okay? But if the river cannot recuperate in the dissolved oxygen level, the river is going to be lost forever. Can you imagine? It's possible. And how dissolved oxygen can come? It can come from the atmosphere in a big way. When there is, jumping, turbulence, lot of dissolved oxygen comes. Again, Henry's law. Dissolved oxygen will come from, oxygen will come from the atmosphere. So what I want to tell you is, if we do not maintain just one parameter, dissolved oxygen in the rivers, we are going to have hell. Okay. Then let us go back to other parameters. And normally the organic matter present, normally we express it as BOD, biochemical oxygen demand. And you can see, normally the standard is less than 2 milligram per liter because we don't want organic matter in the river. And do you know the values? It can go 10 times, 20 times more. And there is another very interesting parameter, we call it MPN, most probable number. Actually, this is a measure of Escherichia coli that is there in the gut. So normally we measure how many Escherichia coli are there in the water. In 100 ml, it should be less than 50 in the river. Why that Escherichia coli is measured? It is an indicator organism. What does it indicate? It indicates the presence of, the likely presence of, the probable presence of pathogens. What are pathogens? Disease causing organisms, cholera, all those things are there. Okay. So the interesting part is, normally these pathogens are very few and they are very weak and feeble. They can be killed easily. So it's very difficult to find out them and measure them. So we use an indicator organism which are better, more sturdy and healthy, which are there in plenty at the same source, human guts or animal guts. Okay. So Escherichia coli is an indicator organism and the number should be less than 50 in any river. Shall I tell you the value of river Yamuna? Again, please hold your desk tight. Some of you may faint. It's not, the maximum is 50, number is 50 Escherichia coli per 100 ml. The value not 500, not 5,000, not 5 lakhs, it can be even 50 lakhs. Can you imagine? The number can go as high as many, many lakhs. Why? Why? It is severely polluted with human waste, animal waste. Very interesting. Then the last one, ammonia. Look at the last value, ammonia. It should be less than 1.2 milliliter per liter. But ammonia comes back in December. In December, the levels, ammonia levels of river Yamuna increases. What is the reason? Something very interesting. So look at the next figure, you will enjoy this figure. So there is a river flowing like this. There is a river flowing like this. And we are taking water from the river and we are treating that water and we are supplying that water to the schools and the houses and the industries. And the used water, that is called wastewater, is collected back and they are treated and released to the same river. Did you get the catch? I will repeat. River Yamuna is flowing or river Ganga is flowing like this, like this, like this. Okay. And you take water from the river Yamuna and there are pollutants in water. You treat it and you compare it with the drinking water standards and supply to the network, water supply network. You get water in your school when you open the tap, right? So you get water. Once you use the water, it becomes wastewater and it goes down to the drain. There are sewerage system drains below the ground and it goes all the way to the sewage treatment plant. You know Okila, have you heard about Okila? Very near. That is the largest sewage treatment plant in South Asia. Can you imagine? We have a huge sewage treatment plant in Okila. All IIT wastewater we are trying to treat here. We have 2 sewage treatment plant in IIT. We are trying to treat our own sewage in the campus and the treated sewage we use for gardening and horticulture. Okay, but other than IIT, I don't know about JNU, but most of the water gets into the drain and goes to Okila. Okay, and after treatment, there are standards for disposal. It goes to the ocean or to the same river. So somebody takes water, use it, puts it back to Yamuna, then immediately another person takes it, use it, puts it back to the same river. Another person takes it, another person means another city or municipality takes it, treat it and dispose it off. So this is a kind of chain reaction. Very interesting, no? So think about river Yamuna. It starts from Yamunotri and comes all the way. All the cities use water and put it back after treatment. In December, what happens? Sometimes treatment is not effective. So ammonia will show up. Carbon is gone, but ammonia will show up. The nutrients will show up. So we have some problem like that in December months. So this is which issue? I don't have to tell you. This is the solid waste issue. You know, there was a strike by Safai Karmachari. You know who is Safai Karmachari? MCD, you know, street sweepers and cleaners. There was a strike few years ago. And this was the scenario. It's a paper cutting. That is why the picture is not very clear. It's a paper cutting. Okay. And Delhi counted all the stars and planets. Although we cannot see all the stars and planets. We were made to count the stars. It was a horrible scenario. So, I will speak little bit about the municipal solid waste. That is the waste collected by the municipality. I hope you understood what I am going to speak to you about. And you know what was happening in early 90s and 60s and when your parents were very young. That is the easiest way to say. Okay, when your parents were quite young, what was the solid waste management system in any city, Delhi or Bombay? You collect the waste, take it far away and you go out of the city boundary and dump it. So the waste is collected by the municipality, taken out of the city boundary and dump it. Now what has happened over years? All the cities grew and all the land dumps are within the city. That is the beautiful part. Not beautiful part, unfortunate part. Okay, Bombay, you have many land dumps which were originally outside the city, now they are all inside. Our Balswa, Ghazipur, Okila landfills in New Delhi, they were all once upon a time in the outskirts, but now they are all within the city. So what happens if they are within the city? Severe pollution, air pollution, noise, dust, all kind of pollution can happen. You know, odor, and even landfill gas, which is mostly methane, is a suspected carcinogen. And leachate, it can cause damage to the groundwater. And unfortunately, most of the land dumps are huge. They are like mountains. I will show you some pictures as well. Okay. So, what government thought? I will show you some land dump. This is the land dump from Okela. This is the land dump from Ghazipur. It's almost like a mountain. Do you know exactly what picture is this? You know, about few years ago, some 150 tons came down. See, it's a MSW, Municipal Solid Waste Mountain, land dump in Ghazipur, 150 tons. It is nothing. When we speak about MSW, we don't, 150 ton is nothing for us. You know how much MSW is generated in New Delhi a day? More than 11,000 tons per day. In New Delhi, every day we generate this waste I showed you, municipal solid waste, 11,000 plus, 11,000 tons, not kilogram, 11,000 tons per day. How many kilogram is 1 ton? 1,000. Okay. So, 11,000 into 1,000 kilogram per day. You can imagine, it's like a mountain. And we have different treatment strategies like incineration plant, waste to energy plants, compost facility, all those things are there. But still, we are actually dumping 4 to 5,000 tons per day. Still, we are dumping every day. Very interesting. Anyway, what you people have to learn is the land dumps are actually very dangerous. So, 150 tons slided down and 4 people lost their lives. This happened about a couple of years back. And this is again a newspaper picture, if I am not wrong. Then another picture I will show you. This is the Belsa land dump. There is many a times landfill fire. You know what is a landfill fire? You can see the landfill is burning. And what is actually burning? There is a lot of methane gas inside. It comes out. And methane burns in air when the percentage of the mixture is 5 to 15%. Okay, methane burns in air when the mixture is 5 to 15% by volume. So, a lot of methane is there inside, and when it comes out, if the mixture is in that range, 5 to 15% of methane and air, it catches fire. If there is a cigarette butt, somebody is smoking and throwing the cigarette butt, there will be a fire. If somebody is intentionally lighting, there can be a major fire. Why intentionally somebody is lighting? They can remove many other things, no? Metals and other things, salvaging is possible. And if nothing happens, there can be natural fires. How? There can be glass. Have you tried burning a piece of paper with a lens? Don't try it again, because Professor Alappat told, don't do it again. If you have not done it yet, please don't do it. But I'm sure you know what I'm going to tell you. With a lens, you can actually burn a paper if you just concentrate the sunlight to a point, is it not? Similarly, there may be a lot of glass in the waste, which can actually, focus sunlight and burn. Okay. So, these fires are very dangerous because you cannot put them out. You cannot extinguish them. Why? There is a perennial supply of methane coming from the inside. Even if you pour water, even if you pour foam, nothing will happen. It will burn to the end. Very interesting scenario. So, what government thought was, we have to treat the waste before land dumps or landfills. So, raw waste is collected, try to recover, reuse and reduce all kind of waste, and waste collected which cannot be recycled or reused will go for some kind of treatment, and there is some recovery happening. For example, there can be composting facility, there can be biomethanation facility, waste to energy incineration facility, fuel making facility. So, a lot of waste is actually processed and there is some recovery happening, and waste good for nothing should go to a landfill. So, this is what I want to tell you. This is the basic strategy behind the solid waste management of any city, whether you are in Paris or in New Delhi or in Cochin or in Hyderabad, no problem. Okay, you collect the waste, reuse or recycle many things and treat the waste which cannot be recycled. There is some recovery happening, and finally waste good for nothing goes to the landfills. The idea is you should separate, you should segregate the waste so that what technology you are using, and that kind of segregation is required at the source. For example, when you came to IIT, did you see 2 containers kept? One blue and green in a cage. I don't know how many of you have noticed it. When you go back, look for that small facility in IIT. There is a cage, and inside there is a blue container and a green container. Green container is for the wet waste, biodegradable waste. Blue container is for the recyclables or dry waste. And why that cage? We don't want dogs or anything to enter into. But now, IIT dogs are so intelligent that they know how to open that cage. You can see them going in and eating and coming out. They are very intelligent, very enterprising dogs in our campus. Okay. So, what I want to tell you is, segregation of the waste at the source is a must to run your composting facility. I know some of the schools do have composting facility. Maybe rotary type, rotating drum composting facility. There are many types, vermicomposting facility using earthworms and, So, in case you want to run it properly, you need to segregate the waste properly. And incineration facility to generate power and fuel making, all those things are actually there. So, since the time is not very much, I will actually move on to some pictures that I will show you. Yeah. I told you about emerging contaminants in the universe. Okay. You know, what are emerging contaminants? There are many compounds, please listen, there are many pollutants which were not there. Now they are appearing. Because we keep on making new compounds in the lab, right? So many compounds which were there once upon a time, which were not there, they are appearing. Some compounds which were there in very small concentration, we never knew about them. Now we are knowing about them. For example, pharmaceuticals. We take, tetracycline and all those things, antibiotics and all those things. And traces of that tetracycline will reach the water body. Because if you take a goli, if you take a tablet, don't think that your body will assimilate 100%. The assimilation is only 20 to 30%. Remaining 70% goes through your urine and your human waste, and it reaches the wastewater. Then I told you, after treatment goes to the river. It's there everywhere. Okay. And there are many other emerging contaminants. For example, some of the pesticides, DDT. DDT is a compound which can mimic estrogen, the female hormone. And why the breast cancer is on the increase? People say that it is just because of many compounds actually mimicking estrogen. I'm not an expert in that area, but I'm just telling you some information. So, many compounds are actually persisting. They don't get destroyed easily. And they persist. And they can reach even Gomukh. It's me and my family. You can see that is not me, it's our Deputy Director of IIT Delhi, the present Deputy Director of IIT Delhi, Professor T.R. Srikrishnan, and my wife and my daughter. This is the Gomukh Glacier. And you can see river Ganga starting. This is the Gomukh Glacier. And river Ganga actually originates from this point. So we were on a truck long ago. It's a 3-day truck. If you hire a vehicle, you can go up to Gangotri in your vehicle. Then it is a 3-day truck. You have to walk around 20 kilometers to reach the base camp, Bojwasa. And then next day you can go to Gomukh and come back another 5 kilometers. So it's a total, one side is about 25 to 28 kilometer trekking with low oxygen, high altitude. Okay. So we went on there, and this is the Gomukh Glacier. And you can see we are actually coming back. And that's me 10 years ago. Quite young, right? And we had a follower also in our visit. That was a dog. Very religiously following us when we are coming back. Why I showed you this picture? Not to show that how I was 10 years ago. It's not that way. Why I showed you this? We collected samples from Gomukh. Not me and Professor T.R. Srikrishnan, our team. And we could see many antibiotics in Gomukh water. Can you imagine? Ganga is starting from Gomukh. We collected sample, not me or Professor Krishnan, but our team collected sample right from that Gomukh. We could see tetracycline, paracetamol, all those things. Unbelievable. Can you imagine this? So why I am telling you, these are all emerging problems that of the future. I am telling you, if there is lot of pharmaceutical compounds in water, what will happen? You take one paracetamol 600 milligram, it won't have any effect on you. Why? You are already immunized. You gained immunity for all those things. You tetracycline, double dose you will have to take because your body is already used to tetracycline. It comes from water. Anyway, not to scare you, but please understand that there are many challenging, emerging environmental problems waiting for you, for the solutions that you may propose. That is why I told you in the beginning, please don't underestimate your capability. You are young. You will get a lot of ideas either now or tomorrow or day after tomorrow. Don't miss those ideas. Discuss with your mentors and teachers. And some of you will actually become real scientists and engineers. That is why in the beginning I told you, I am envy of you. Because I don't think I can become a better or a very super, engineer now. I don't think. We are all stabilized, but he has a long way to go. But I, I am almost stabilized. Okay, and you can see even in the Arctic. Can you see some people? They are not people; they are penguins. Even water samples from the Arctic and these kind of remote areas, they are having samples of traces of pharmaceuticals and these kind of compounds. Very interesting. Anyway, I will stop now just with few slides. So we have to learn from the nature. This is one thing which I recommend to you. Observe the nature, the plants, the trees and the birds and the flies, and you will get a lot of ideas from the nature. I am telling you, if you look at many things, people have picked up from the nature. My shoes has a Velcro. You know how Velcro was made? Somebody used to go for jogging in the morning. And when he comes back, he noticed that a lot of things are sticking. That plant, ek plant hai, uska that plant ka seeds are sticking to his shoes and other things. So he has an idea, why don't I use these plants to stick? So Velcro came. See? So ideas click. And Velcro was actually made because of this incident. Somebody running, jogging in the morning and coming back with a lot of things sticking to his pants. So, have you heard about beaver? Beaver makes excellent houses. You know why it is excellent house? You can see this is the beaver and he makes a small dam to ensure that his house is safe. So, anybody wanting to go to his house will have to pass through this artificial tunnel filled with water and he is very safe here. Beaver, a master civil engineer. So, this is his house. Beaver's house. Okay, I am not joking. You can Google today night, not now. Today night you can see and read about beaver. See the intelligence. So beaver makes a small check dam and there is a water-filled tunnel and beaver lives here aramse. Then, have you heard about Siberian cranes migrating to India? There are many birds that fly thousands of kilometers, not 1,000 to 10,000s of kilometers. And Siberian cranes used to come to Bharatpur Bird Sanctuary because I used to go there every year. Recently they told that, sir, ye band ho gaya. Siberian cranes are not coming now because they got extinct. They are not coming to Delhi. And he was telling that route is closed. You know what is that route is closed? The route is lost. Even if there are Siberian cranes in Siberia, the young people do not know how to come to India now. And we could see a lot of migratory birds. There is something called bar-headed goose. You can search at night, not now. Give a Google search. Bar-headed goose. It's a kind of duck. Very pumpy duck. Do you know what they do? They come from that Mongolian side. They cross over Himalaya. Can you imagine? They fly above Himalaya, come to India and reproduce. They have their children and they go back. Very interesting. They will take test flight. Do you know how they fly? They go in a formation. The strongest one at the front and at the wings, 2 people, because at the wings it is low pressure. So the strongest one on the front, at the wings, 2 people, at their wings, another 2, like that it goes. So they fly in a formation because they have to fly 10,000, 15,000 kilometers without any compass. So what is happening? You can learn a lot from them. Another very interesting thing is, if you see this, somebody picked up that shape of that kingfisher and put it to an electric train. And he could save, he could actually reduce the power consumption and he could get higher speed. So Japanese company that did it actually. These are not jokes. These are our reality. It's not my making. See the peak of the kingfisher and the peak of the front side of the train. See the wings of the aeroplane and what the bird does. If you have not traveled in an airplane, when you travel next time, you look through the wings. When they take, the flap will be doing something like this. When they land, the flap will be something like this. So trains' wings are having flaps. They are actually generating or slowing down the plane, accelerating the plane, giving a thrust to exactly mimic from that of a bird. Very interesting actually. So what I want to tell you is, there are a lot of things to learn from the nature. For example, jugnu. You know what is jugnu? Jugnu produces actually a small light only. Very little light Jugnu produces. But the design of the belly, that Jugnu's, that area is in such a way that the light amplifies. So somebody put the similar thing for LED and he is telling that he got 55% more brightness. Sir will be very happy because he is from the design department. So, lot of things you can pick up from the nature. And there are actually ant colony optimization algorithms. I am not good in these kind of things. Artificial bee colony algorithms. So, people take a lot of tips from the algorithm, I mean, the way the ants behave, the honeybees behave. Anyway, I don't want to get into these things because I cannot explain these things. But what I want to tell you is, you can learn a lot from the nature. If you can get some solutions from the nature, that will be the best. Why? Because those solutions are actually time tested. Tested over years and years and years. So if you can get some solution from the nature, please understand that is the best. You look for that, you will get solution from many of the problems, whether it is environmental or whatever it is. Okay. So I just want to give you a few tips, not advices, something you can ponder perhaps. Life and environment is invaluable, means there is no value assigned to it. It is so valuable, life and environment. And second thing, I always feel that science and religion are two sides of the same coin. Both are searching for truth in their own way. In science, we do experiments, we have mathematics, we have theory. In the religion, there is another way of exploring truth. So, I am tempted to tell you, not advise you, I am tempted to tell you that science and religion are actually more or less the same. It may be a dangerous statement I am making in IIT, but it's okay, no problem. Okay. Then another interesting thing is, knowledge is supreme. Whatever it is, all kind of knowledge are useful and may be integrated. You keep your ears open, you keep your mouth shut, but all other things open. Okay. Your nose open, eyes open, ears open, so that you can learn, and learn and learn. Because knowledge is actually power, supreme power. You know how life is defined? Life is defined as a pack of knowledge. Life is nothing other than knowledge. When some molecules, some chemical concoction, some molecules found their way and they acquired their knowledge to multiply, that was the origin of life, according to the present day wisdom. Anyway, so I stop here and thank you very much for coming over here and listening to me. And I really do not know how much I told you, how much you picked up. My idea was just to tell you that you have a long way to go. Keep your eyes open. Try to learn as much as possible. Okay. In your life, every learning is actually an asset. So don't hesitate to learn anything that comes on your way. Driving, music, swimming, science, philosophy, psychology, anything that comes on your way, it will be useful to you one day or other. That's all. Once again, thank you very much and I wish you all the best. Thank you. Thank you.